faster. Okay, optimization means making the spanning tree run faster. What we can do to make the spanning tree run faster? Okay, so as we have seen that whenever on a switch, if you connect any of the PC, any of the device, if you connect, or any of the device, if you connect on a switch port, what the switch port will do? Switch port will run a spanning tree protocol. It will automatically run a spanning tree protocol. Correct? So it will run a spanning tree protocol, and it will check whether there are any loops in the network that we have connected. Okay, so if no loops are found, then the link will come up automatically. Okay, so what we can do to make the link up, we don't have to wait for spanning tree on the access port. Like if I connect over here, if I connect one PC, now PC will never send a BPDU message. Correct. So if I am connecting a link to the switch will still run spanning tree protocol over here. See, it is still running the spanning tree protocol, but it will never receive a BPDU message from the PC. So what I can do to make this port up immediately, to make the port up immediately when I connect, so I can use something known as port fast. Okay, port fast will make my port up immediately when I connect it. When I connect PC to, or when I connect anything to the port fast port, it will make the link up immediately. It will not run spanning tree. It will skip the spanning tree process. Correct. So what I will do now, I'll make the port as port fast over here. Okay, let it get translated. Enable, say no IP domain lookup. Okay, then I'll say interface range. I'll make interface fast Ethernet 0/124. I'll make them as port fast. So what command I need to give over here to make them port fast?
Spanning tree port fast? Or
Yes.
just port fast?
Spanning tree port fast. Have to give a command spanning tree port fast. When you give the command spanning tree port fast, you will get a warning message. Port fast should be enabled on the ports connected to a single host. Connecting hubs, concentrators, switch bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. Okay, so okay, we have connected. We will be only connected now. These are my access ports. We will be only connecting PCs over here. Now, if I show you over here, if I connect a PC on the next port, then the port will come up immediately. See, it came up immediately. It is not running spanning tree. Okay, so this is something port fast. Now what will happen if I connect a switch over here? Okay, by mistakenly what I did, I don't remember, or my junior engineer, he didn't remember, and what he did, he just connected a switch on the port fast port. Might be possible it might have loops. Okay, might be possible there is another switch over here in the network. Okay, and this switch is connected with this switch, this switch is again connected with this switch, so might be possible it will form a loop over here. Okay, so what we can do to prevent the loop over here, what we can do to prevent a loop over here, if by mistakenly I connect, see, this will not run spanning tree, it will skip spanning tree. The port will come up immediately. Okay, so what I need to do if I need to secure my network more, so BPDU guard will secure your network more. Okay, if you want that, if something is done by mistakenly, if something, a switch is, or something is connected, a device, a switch is connected on a port fast port, then it should, a BPDU guard will, what it will do, prevents if another switch is attached to the port fast port. Okay, it puts the port into error disable state. Basically, you can say shutdown state if BPD is received on the interface. Okay, if any port fast interface will receive BPDU, then the port becomes in error disabled state. The ports go into error disabled state. The another thing is BPD filtering. Okay, if port fast interface receive any BPDU, it is taken out of the port fast port. If we enable BPDU filter, so we will see the theory part of BPDU guard. BPDU guard prevents loop if another switch is attached to port fast port. When BPDU guard is enabled on an interface, it is put into error disabled state, shut down, if a BPDU is received on the interface. Port fast does not need to be enabled for it to be configured at a specific interface. This is BPDU guard. BPDU guard will make the port in shutdown state. But what the BPDU filter will do, we have another option over here, BPDU filter. BPDU filter will just make the port, when a BPDU is received, it is taken out of the port fast status. Okay, the interface still sends some BPDU at the link up. If a BPDU is received, the interface loses its port fast status and BPD filtering is disabled. The interface does not send any BPDU and ignores the received one. Means the filtered interface will not send any BPDU and it will ignore whatever the BPDUs are received. The port is not shut down, and this basically disables spanning tree on the interface. If no BPDUs are sent, the spanning tree will be disabled, because spanning tree runs if BPDUs are exchanged. Okay, so if I want to see BPDU guard, okay, what I need to do, if I need to enable BPDU guard, what I can do, I need to go inside the interface range, whatever the interface range is there. Okay, interface range, I'll say spanning tree BPDU guard enable. Spanning tree BPDU guard enable. Once I enable the BPDU guard, you can see the link went down because the switch number 1 has sent a BPDU message, and whenever the switch will receive a BPDU message on a port fast interface, it will make the port as shut down. You can see if I open the switch, I got a message, error disable. BPDU guard error detected on port number 0/3, putting into error disabled state. I can check show interface status. See, port number fast Ethernet 0/3 is in error disabled. Now, how the link will come up? If I disconnect this switch, if I delete this switch, and if I connect a PC over here, will the link come up automatically? No, the link did not came up automatically. What I need to do to make the link up? See, I have removed the switch. So I need to go inside the interface fast Ethernet 0/3 and I need to say shutdown and no shutdown. Once I say this, then the link will come up, and if it does not receive any BPDU, then it will remain up. If again it received any BPDU, then it will go down. Like if I connect this switch, once it receive any BPDU over here, it will make the link down. But if I delete this link over here, the link fast Ethernet 0/4 will not come up. If I make the interface up fast Ethernet 0/4, if I say shut down and if I say no shut, the link will come up. See, the interface will come up. Okay, change state to down. If I see show IP interface brief, the interface is down because we have not connected anything. But if I connect a switch over here again, the interface came up, but again when it receives the BPDU, it will go down because we have enabled BPDU guard on the interface. Understood?
One question here, okay.
Yep.
Error disabled means always means BPDU guard.
Error disabled always means BPDU guard means I didn't got you.
if we see a error disable option against
Mhm.
the port, does this mean always it happens because of this, or there is
No,
other
no, no,
reason
no.
also?
There might be other things also.
So how do we know that this happened because of BPDU received on those ports?
Okay. How we know that if we have received? So if we will connect a switch and that port is a port fast port, then you will know. You can see in the configurations that what configuration on that port is done. If that port, if I see over here show running configuration, I can
Okay.
see that I have enabled BPDU guard on this port and this port is port fast port. So I will be knowing that why my port is going down.
Okay.
Okay.
Understood. But is there any way to check why this error disabled? Is it disabled because received BPDU, which is not expected from that port?
Sorry, come again.
Is there any way to check reason behind error disabled on the switch? Uh,
So you will come to know the reason. That is what I am explaining you. The reason is if you enable BPDU guard on a port fast interface, it will go in error disabled state. This is the reason.
okay.
So you will come to know by this thing only. When you see the running configuration, what is the configuration that I have done? If there is a BPDU guard enable on a port fast interface, that means it will go in error disabled state. It does not mean that this is only the reason. There might be another conditions also. Like if I see the configuration that this is not the condition, then what is the condition that the thing is going into error disable? That might be different conditions.
Okay.
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 I
Got it.
think one question he had was, can you show the console log that popped up when it went error disable? I think that's what he was wanting to look at.
This is the console.
And
This is
and
the
it
message.
and it says right there,
Yeah.
if that helps
Correct.
you.
So here the console we can see, right? Let's say
Yes.
why I'm asking this here, because there was a big topology, and on this topology, uh,
Yeah.
I was
Okay. So
seeing
you were
error
asking how we will
disabled,
come to know. So you
error
will get a
disable
syslog
against a
message.
port.
I shown you previously only on the fast Ethernet 0 slash
Yeah,
3
yeah.
port that
But
you will
this
get a
console comes and go, right? It will not be there permanent. If I open another, SSH, then I won't see this console, right?
yes. I'll not see
Yeah,
this console.
yeah. So that's why.
So
Anyway, I got it.
yeah, if you take a console, if you take a telnet access, then you have to enable the syslog for telnet access. Okay, if you're taking a telnet access, you will not get automatically the syslog messages for the telnet access. Okay, so you have to enable it, and if you want to see that what is the configuration, then you have to see the show run configurations. Understood?
Yep, got it. Thank you.
Okay, so now this is the manual error disable recovery. Now we have something error disable recovery with the help of some automatic error disable recovery. Like if I want that if error disable cause is for the some, I can keep some interval. Okay, like I don't think so I'm having the option over here in packet tracer. I don't think so. No, I'm not having the option over here. Let me open EVNG. Okay, the thing is that EVNG will be running by default the rapid spanning tree. EVNG will by default run the rapid spanning tree, and in the rapid spanning tree, the BPDU filter, BPDU guard, and this port fast is the port fast is there. BPDU guard is, I don't think so. It is there. Let us check. We can see the configuration. Okay, so let me check if it got on root 192.168. Sorry, this is not the IP. 202.130. Okay. Close the lab. I can take a test lab. I can take this STP lab only. Open. Start selected. enable show spanning tree. So it will be running RSTP by default. Let me check if I am having error disable. See, this is something error disable recovery cause and interval. I can set an interval. I can say I can give any timer. I can say 30 second, or after 30 second the link should check automatically. The link should come up automatically, and again if it receives the BPDU message, it will go down again. Okay, so it is automatic recovery. This is something automatic recovery. I can give error disable recovery interval. I can give any interval. Okay, and I have one more option as cause as BPDU guard, cause BPDU guard. Okay, cause as BPDU guard. One, I give you this command. If anything, see what is this? You have to give two commands: error disable recovery. And if the cause is BPDU guard, then what you have to do? You have to make the recovery in specified interval. Suppose 30 seconds. If the cause is BPDU guard, we can give any other cause over here, like ARP inspection, channel misconfiguration. There are many things. Okay, if any of these are the I now right now we are studying about BPDU guard. If the port is going down and the cause is BPDU guard, then you have to select this interval. You have to make the link up after 30 seconds. And if the link comes up and if the switch does not receive the BPDU on that interface, on that port, then you can then the port will remain up. If it again receives the BPDU guard, then it will go down again. It will go into error disable state again. Understood? So this is something automatic recovery. This is something automatic recovery. Now we have something known as filter, BPDU filter. Now BPDU filter is something like it will not make the port down. It will not make the port down. Okay, if anything is received, the port will be up. Now, and from the CCNA syllabus, I am having some documents for this thing, BPDU guard and BPDU filter. BPDU filter. So if a port fast interface receives any BPDU, it is taken out of the port fast status. Okay, how you can enable in the global configuration mode? You can say spanning tree port fast BPDU filter default, and in the interface level, you can say spanning tree BPDU filter enable. Okay, the interface does not send any BPDU and ignores the received ones. The port is not shut down, and this basically disable the spanning tree on the interface. Okay. Understood BPDU filter? This is we have studied at the CCNA level also. I'm just revising the things. So to enable the BPDU filter, you can say spanning tree BPDU spanning tree. What was the command? Spanning tree port fast BPDU filter. Port fast BPDU. Here I'm not having the option. I can check in the interface E0/0 whether I'm having the option. Spanning tree BPDU filter. BPDU filter, spanning tree BPDU filter, and enable. So this is the command that you can give for spanning tree BPDU filter. Okay, and I'll make spanning tree port fast. Okay, spanning tree port fast. Understood? This is the command that we need to give for BPDU filter. Next thing to optimize the spanning tree is root guard. Now root guard is something like that will prevent the wrong switch for becoming the spanning tree root. Now wrong bridge means wrong switch means, what do you mean by wrong switch? There will be no wrong switch, right? The switches will be correct only. The wrong switch means, what do I mean by wrong switch? Suppose I am having a enterprise network. I am having an hierarchy. Let me draw a hierarchy. Suppose this is my switch. These are my switches over here in layers. Okay. Here also I am having a switch. Now this is an hierarchy. This is my switch A. This is my switch B. And these are some 3560 switches. Okay, 3560 switches. And these are some, you can say, 2950 switches or 2960 switches over here. Now the connections are made over here, like the connections are in this way. Some, okay, these switches are connected with each other with ether channel configured. Okay, and these switches connected with all the other switches. Okay, this switch is also connected with all the other switches. And this switch is connected with this switch, and this switch. This switch will be also connected with this switch, and this switch for redundancy purpose. Okay, now what I want, suppose these are my multi-layer switches over here. Now what I want that this switches should always become the root bridge. This switches will always become the root bridge. So what I can do, if I have a hierarchy over here, now what can happen at some time, that suppose this switch fails. Okay, this switch fails. Now what happened over here, that this is having something in lowest, you can say lower bridge ID. Okay, lower MAC address or something. Now this switch failed, and what I did, I had another switch in my storeroom, and what I did, I replaced this switch with another new switch. Now what is the condition over here, that this switch is the new switch that I have connected over here. This switch is having the lowest bridge ID from the bridge ID as compared to this root bridge. Okay, root bridge. So it will send BPDU messages over here on the link. Now once the BPDU message is being shared, what will happen over here, that this switch will also share a BPDU message, and this switch will be having the lowest bridge ID, so this will become the root bridge now. So we don't want this switch to become the root bridge. Okay, so if root guard port receives a superior BPDU, that might cause it to become a root port. Okay, now if this switch is becoming the root bridge, this port will become the root port. Okay, so if that port is, if you receive a BPDU message and that might cause it to become a root port, okay, the port is put into root inconsistent state and does not pass any traffic. If we enable root guard on this, it will go into root inconsistent state and it will not pass any traffic. Okay, and when it will come up, if the port stops receiving the BPDU message, it automatically re-enables itself. This is known as root guard. Now why we need this thing? We need this thing in something like if we have a service provider environment. Okay, how we can have a service provider environment? Suppose this is a switch over here at the customer side and another switch over here at the customer side, and this is something division between the customer side and the service provider side. Now we are having some switches at the service provider end. Okay, like these are the switches at the service provider end. Okay, at any switches you can take. Now these are connected with each other in this way, you can say. And these switches are connected with this switch, the customer end switch. Okay, and some more connections are over here. Some more connections are there with the switches at the customer side. Now what will happen over here? This is my customer site and this is my service provider site. Now what will happen over here if you don't enable root guard? Okay. Now if you don't enable root guard, they are in a network. So what they will consider, see, they are forming a loop. So what they will consider that I am the root bridge. Suppose the customer site switch is having the lowest bridge ID. So what it will consider, okay, I am the root bridge. I am the root bridge, which you don't want. Which you don't want, with the service provider will don't want. So what it will do, what the service provider do, they will enable these ports as a root guard. They will enable these ports as root guard. Enable the root guard, okay, feature on these interfaces to prevent switches in the customer network from becoming the root switch or being in the path to the root. So in this type of network also we need something known as root guard. So what the root guard does, it will make the port into root inconsistent if it receives a superior BPDU. Got it? Understood?
Got it.
So root guard is, you can say, similar to BPDU guard feature. Now in the manner in which it is used to detect STP packets, okay, and it disables the interface they were received on. Now the difference between root guard and BPDU guard is, root guard, the interface is only logically disabled via root inconsistent state. Okay, if a superior BPDU is received on the root, on the port. But what was happening with the VPDU guard? VPDU guard was making it shut down. It was making it shut down. Now root inconsistent state is similar to blocking state. Okay, in that BPDUs are not sent outbound but accepted inbound. Correct? In blocking state, BPDUs are not sent outbound but it receives the inbound BPDUs. Correct? So you can say all received frames are dropped. Whatever the frames are received, they are dropped. Now the switch automatically recovers the port from root and inconsistent state. Okay, it starts negotiating the port state and role as soon as superior BPDUs are no longer received. Okay, if it stops receiving the superior BPDUs. Now a superior BPDU indicates a better cost to the root bridge. Okay, then what is currently installed. Superior BPDU means what? Better cost to the root bridge. Now, if I am having the better bridge ID, if my switch, that if we see in this example, if this switch is having the better bridge ID or bridge ID, then this switch will say, okay, I can only become the bridge. I can only become the root bridge. Okay. So therefore, in terms of design, this feature is used to prevent a rogue device. Okay, a rogue device from announcing itself as a new root bridge. So suppose someone has connected a rogue switch and it is announcing itself as a root bridge. So it can prevent that thing also, and possibly implementing a layer 2 man in the middle attack. Okay. Now root guard can be you can say enabled only at the port level and basically prevents designated port from becoming non-designated. Okay, so you will want to configure this functionality on root bridge itself. Okay, so let us see how we can configure. So these are the devices. I'll stop so that the configurations get deleted. Start. Start selected. Reconnect. Now this is something, this is running RSTP by default. There is no issue, we can see in that also. But let me check if I am having something over here. Okay, these multi-layer switches will be running. They will be running STP, normal IEEE STP, because RSTP is something functionally different. Okay, and STP is something different. So I have enabled 2 VMs. That is the reason it is running slow. Show spanning tree. So show spanning tree for VLAN 1. Spanning tree. Okay, have connected fast Ethernet 1/0. Now we are the root for spanning tree. This
Why
is
is there any reason why the link go down?
Sorry? Come again.
Yeah.
What are you saying? Hello. I guess you are asking something to me. Root port is fast Ethernet 1/0. Okay, this is the root bridge. Ethernet switch 1 is the root bridge. Okay. Now to enable BPDU guard, to enable root guard. Okay. So what I need to give the command. Now I'll go over here and I'll check. Now my switch, Ethernet switch 1 is the root bridge. Okay, I've shown you this is the root bridge. Okay. Now I'll configure STP over here. Okay, I'll configure switch 1 so that STP logically blocks the Ethernet links connected to switch 2 if any of the port switch 2 tries to become the root bridge. Okay, so what I will do, I'll make one of the port over here. I have two ports, 1/1 and 1/1 and 1/0. Okay, two of the ports are there over here. What I'll do, I'll make one of the port as, I'll say, interface fast Ethernet 1/0. Spanning tree. I'm not having an option. It is not giving me the option over here. Spanning tree. Yeah, here I am having an option guard, spanning tree guard, and you can see the last one is root. Spanning tree guard, root guard. This will enable root guard. Okay, you can see root guard is enabled on this port Ethernet 0/0. Okay, now I'll connect. Okay, I have to make this switch stop this switches, then only I can connect another link. So I can see in one link also there is no need to connect another link. Okay, so I'll reconnect it. I'll take the console of this switch also. enable show spanning tree. This bridge is the root bridge. This bridge is the root bridge. If I see over here, this translation does not
I
get
think
it.
you can stop Control-Shift-6.
No, it is not getting stopped in my laptop. What is the issue? I don't know. Enable no IP domain lookup. Okay, so show spanning tree. The root bridge is, this is not the root bridge. Okay, switch 1 is my root bridge. So to enable root guard, I want this switch only to become the root bridge. So what I can do, interface 0/0. I'll say spanning tree guard root. Root guard is enabled. Now what I'll do, the priority is 32769. First it will check the priority. Here also the priority will be 32768 by default. Okay, then it'll go to MAC address. Now what I can do, I'll make this switch to priority as 0 or any lower priority. I'll say spanning tree VLAN 1 priority, you can say 0. Show spanning tree VLAN 1. It should go into the root inconsistent state. See, spanning tree root guard block, root guard blocking port Ethernet 0/1. Show spanning tree VLAN 1. See, blocking port. It went into root inconsistent state. It went into root inconsistent state. Now see, this bridge is showing me as also root bridge because it is not receiving any BPDU messages. So it will also it will consider that I am the only one in the network. I am not, there is no one else in the network. I am the only one in the network. Okay, priority is 1, the default VLAN ID, system extension. Here the priority is, now the port will go into blocking state unless I will change the priority over here. Okay, unless I'll change the priority over here, the port will not come up. So what I need to do, I need to say, I'll remove this command, no spanning tree VLAN 1 priority 0. See, root guard unblocking port. So you will see over here now, it will unblock the port. Okay, it will come up in some time. See, learning state. Okay, so it will come up. Now no longer it sends the BPDU. Okay, when I am not having, when the port is in blocking state, it will not send any BPDU message. Got it? This is something. This is what, this is something root guard. Okay, understood? Any doubt in root guard? Any questions for root guard?
Nope.
Okay. Then we have unidirectional link failure. Now what happens sometimes, the cable is intact enough. Okay, the cable is correct. There is no issue with the cable. Okay, to maintain the keep alive status, you can say it is telling me the port is up. Okay, but it does not pass the data in both the directions. Might be possible sometimes what happens, that this link, this switch can send the BPDU message, but this switch is not receiving the BPDU message. Okay, sometimes what happens, that the switch over here is able to send the BPDU message, but it is not, this switch is not able to send the BPDU message because there is some issue with the link over here. Okay, or sometimes BPDUs sent by B are not, switch 1 are not received by switch 2. Okay, so you can say that port is still blocking. Okay, the port is still blocking. So this type of situation is known as unidirectional link failure, unidirectional link failure, or you can say UDLD. Let me check if I am having any diagram for this. Okay, I'm not having any diagram. Unidirectional link failure. This is known as unidirectional link failure. See, the port will be up. You will see the port is up and there is some issue with the link. Okay, there can be any issue. Link for which the one of the two transmission paths on the link has failed. Okay, but not the both. One can send the message, the other cannot send the BPDU. Okay, this can happen, you can say, as a result of you miscabling. Okay, miscabling, or you can say cutting one fiber cable or unplugging one fiber, or might be other reasons. There might be other reasons also. So no longer receives spanning tree BPDUs. Still it is forwarding the traffic. Okay, so now what will happen? Suppose we are having some 3 switches in a triangle way. Okay, we are having one more switch over here and this switch is connected with, suppose we are having one more switch over here, these 2 switches are connected in this way. Okay, now one of the port will be in the blocking port. Suppose we will be considering this port, well, this port was in the blocking port, and the link between, this is my root bridge, and the link between 1 and 2 has gone unidirectional. It is unidirectional link failure between 1 and 2. Unidirectional link failure. Now what will happen over here? The blocking port from the alternate, or you can say backup port, becomes designated port. This will become now designated port and moves to the forwarding state. Okay, now this situation will create loop. How it will create loop? Now the traffic will be sent from here, it will go over here. Now this switch 1 is able to send the traffic again over here, but the switch 2 is not able to send the traffic. Okay, so this will form a loop. This will form a loop again. Okay, so this is called unidirectional link failure. This is called unidirectional link failure. Understood what is unidirectional link failure? Understood?
Yes.
Yep.
We have 2 solutions for it. One is loop guard and another one is UDLD. First one is loop guard, another one is UDLD. We'll see one by one. Loop guard. Loop guard stops the loop which occur because of unidirectional link failure. It will make the port inconsistent. It will make the port inconsistent. It will stop the loops which can occur because of unidirectional link failure. You can say it prevents switch ports from wrongly moving from a blocking to forwarding state. Okay, when a unidirectional link exists in the network. Okay, so as I told you the example, the blocking port will go into the forwarding state. What the loop guard will do? The loop guard will make the port into loop inconsistent state, you can say, to loop inconsistent state. Okay, preventing the loop. Understood? Getting me or not?
Yeah.
Okay. Now, how to configure loop guard? Now, loop guard can be enabled on either, you can say, designated port, or it can be enabled on root port, or it can be enabled on alternate port. Okay, to enable loop guard for all point-to-point links on a switch, you have to give the command spanning tree loop guard default. Spanning tree loop guard default. Automatically it will loop guard, it will make for all the point-to-point links. Okay, now loop guard will automatically re-enable the port if it start receiving BPDUs. Okay, if it start receiving the BPDUs. To enable loop guard for all point-to-point links on a switch. Okay, understood?
Yes.
Then we have unidirectional link failure. Second solution, UDLD, unidirectional link detection. Now this is something a Cisco proprietary. This is something a Cisco proprietary. Now it works same, do the same job as the loop guard does. Okay, now it is designed more specific for fiber ports. Okay, it can also work for UTP ports also, but it is more specifically designed for fiber ports. Now it detects unidirectional link by sending periodic hellos out of the interface. Now what does this mean? Periodic hellos. Now suppose I was having a switch over here. Okay, these are connected over here. Now the link between the 1 and 2 became unidirectional link failure. They are facing with unidirectional link failure. Now what will happen if I suppose enable over here on both the ports, if I enable on both the sides on switch 1 and switch 2, if I enable unidirectional link failure, so what it will do, they will send a periodic hello message. Okay, they will be sending a periodic hello message out of the interface. Okay, so it also, you can say, uses probes, okay, which must be acknowledged by the device on the other end of the link. Okay, so it is sending hello message periodically, so it will also send a hello message periodically because we have enabled over here also. So hello message will be sent on both the ports, and it will come to know that if the link is unidirectional or not. Now we have two modes in this UDLD. We have two modes. Okay, so the modes are see, it is designed specific for spice. It is designed specific for fiber ports but can also work for UTP cables operating at layer 2. UDLD detects the unidirectional link by sending periodic hello out of the interface. Okay, so to enable UDLD on all fiber interfaces, you need to give command in the global configuration mode UDLD enable or /aggressive. As I told you, we have two modes. One is the normal mode and one is aggressive mode. To enable UDLD on non-fiber ports, UDLD port aggressive or disable. What is normal mode and what is this aggressive mode? In normal mode, the link status is changed to undetermined state if the hello are not returned. So if I will not get a periodic hello, in the normal mode, the state will be undetermined. The state will become undetermined. Okay. And in aggressive mode, the port is in error disabled if unidirectional link is found. Okay, this is the recommended way. So in this way also the port can go into error disabled state. Understood, Pawan?
Yes, yes.
You only asked this question, right? So in how we will come to know. So there is nothing like in BPD guard only the port goes. There are many ways in which the port can go in error disabled state. Okay, so one of the ways unidirectional link failure. Okay, now to make the interface up, what you can go into manual things, like you can go in the interface and you can give shut no shut command, or what you can go in the global configuration or in the enable mode and you can give this command UDLD reset. Okay, to re-enable all interfaces shut by UDLD. If you have more than one interface that are shut by UDLD, you can give this command in the enable mode, UDLD reset. If it will reset all the UDLD configurations. Okay, understood? If you want, I can give you the difference between UDLD and you can say the unidirectional link failure. So
And none of these are set by default, correct? You have to globally set them or what have you.
sorry?
None of these are set by default. I'm just curious. It seems like you would want them set by default. Are they resource intensive? Like, what would be the purpose of not enabling these?
What will be the purpose of not enabling what?
He's asking these are the default. These are enabled by default on the switches. If not,
You have
why?
to enable.
Because of
You have to enable this thing.
Right. You have to enable it. My question is, why would you not enable it? It seems like you would want to have this enabled. Is it resource intensive? Does it take up a lot of processing for the switch?
It does not take much of the process, but sometimes what happens that we don't want that our switches should run. It should run much commands, or we sometimes what we want that we don't need to configure much things. Okay, about laziness or something. I'm lazy person, so I will not configure UDLD. Okay, I will not configure UDLD. No issues. I don't want to configure. See, it is the best practice. You should configure these all things when you are running spanning tree to optimize the spanning tree. Whatever we have studied to optimize the spanning tree, these should be configured for optimizing for running the spanning tree in a good manner.
I got you. So it
This
is
is the
best
best practice.
I understand. Thank you.
Okay. So if I give you the difference between the things, if I see the functionality, so first we will see the functionality, then the second column can be, you can say, for loop guard, and the next column can be for UDLD. What is the difference between the functionality? So as per configuration part, configuration, you can say per port configuration is there. Here also same per port configuration is there. Action or action granularity, you can say for VLAN you can enable this thing, and you can enable this as per port. And if I say auto recovery, auto recover, so loop guard will automatically recover. This will not, this will also automatically recover. Okay, you can say with error disable timeout feature, you can say timeout, like whatever we have seen, automatic timeout feature. Okay, and what we can see, protection, again something like protection against miswiring. So there is no protection against miswiring in loop guard. It is having a protection. Okay, like it will send a hello messages and you will automatically come to know. So this is something my UDLD and loop guard. Understood?
Yes.
Now we are having something more, like if I go in depth about the error disable. Okay, error disable, and you can say error disable recovery. Okay, so now the port is automatically disabled by the switch operating system. Okay, software, because of an error condition. Okay, that is encountered on the port. Now when the port is error disabled, if it efficiently, so you can say if it effectively if it is effectively shut down and no traffic is sent or received on that port, Now the port LED is set to the color orange. Okay, the port, you will see the amber color on the port LED. Okay, so how you can check? You can check with the command show interface. You can give show interface, the interface number, suppose fast Ethernet 0/1 status, if you want to be specific. Or you can give show interface status. It will give the status of all the interfaces. Okay. Now error disable recovery. Why we need error disable recovery? Now there are some reasons for error disable state. Why the port goes into error disable state? The first reason is, you can say there is a duplex mismatch. This might be a reason. Duplex mismatch might be a reason. Or you can say port security violation might be a reason. Port security violation might be a reason. Or you can say UDLD failure, Bpd guard, as we have seen, and broadcast storm. Broadcast storm will be also making the port into error disable state. Or you can say unicast flooding. Unicast flooding will also make the port into this. Or one more thing is there, the hardware problem, like link is flapping. Link is flapping. Link is flapping. It is going up and down, up, down, up, down. Okay, link is flapping up, down, up, down, up, down. Some port issues or something. Now in this, these are the reasons the port goes into error disable state. Okay, now error disable recovery, to recover a port that is in the error disable state. Now administrator must access the switch and configure the, you can say, the specific port with shutdown followed with no shutdown command. Okay, so what we can do, we can use error disable recovery options. Okay, so there are many options, as I told you, for error disable recovery, like UDLD, Bpd guard, security violation, okay, channel misconfigure, okay, PAGP flap or DTP flap. There are many options. Okay, so you can make the error disable recovery, or you can select any cause of error disable. If this is the cause, if Bpd guard is the cause for error disable, then make the port up after these many seconds, after this many interval. Okay, so this is something, my error disable recovery. Okay, we can make to enable the, we can do error disable auto recovery also. Auto recovery means to enable the error disable auto recovery feature for, you can say, all the supported reasons. So you can give over here for all the supported reasons. What you can give, you can go on the switch and you can say config terminal, you can say error disable recovery, and you can select a cause as all. Cause as all, we'll be having an all option over here. If I select all, it will be auto recovered if there is any of the, if any of the reason was there for the port to go into error disabled state. Understood?
Yes.
Okay. Now if in now we have something in spanning tree, we have uplink fast and backbone fast. We have two features. Now uplink fast is something like, if in normal spanning tree, if we are running a normal spanning tree, okay, and suppose I am having a switch over here that is connected in a tree. Now this is my blocking port over here. This is my root bridge. And as we have seen, as if you remember, Agrima and Robert, we have seen at the CCNA level, okay, that this was my topology that I've made. This is my switch 3, this is my root bridge, and this is my blocking port. Now for this switch, this is the direct link and this is my indirect link. Okay, the switch that is having a blocking port. Okay, so in the normal spanning tree, the legacy spanning tree, IEEE spanning tree, the problem is that my direct link goes down. If my direct link goes down, then the alternate link will come up in 30 seconds. If this link goes down, okay, this link goes down, then this link will come up because this blocking port will go into listening and learning state for 15 and 15 seconds. It will take 30 seconds to come up, the alternate link. Okay, this will take 30 seconds to come up. But what if my this indirect link goes down? If my this link goes down, now my switch 1, or you can say switch 3, this is my switch 3, has to go via this route, okay, to the root bridge, because this link has been failed. So switch 3 has to go via this way. Now if my indirect link fails, this blocking port will be in blocking state for 20 seconds. And then it will go into listening, and then listening for 15 and learning for 15. So total time it will take is 50 seconds, okay, to come up, 50 seconds to come up. Understood? Direct link and indirect link failures. So we have something known as uplink fast and backbone fast. For normal spanning tree, we have uplink fast and backbone fast. Now what does this uplink fast and backbone fast does? If I enable uplink fast and backbone fast on this switch, if my direct link goes down, then this link will come up, the alternate link will come up within 1 second, within a second. And if I enable backbone fast on this switch, if my indirect link goes down, then this alternate link will not be, it will directly move into listening state. It will not wait for 20 seconds in the blocking state. It will directly move to the listening state, listening and learning. So it will come up into 30 seconds. For switch 3, this link will come up into 30 seconds. Understood? This is something uplink fast and backbone fast. Any doubt?
Yes, the backbone, if you can clarify it once again, please. The backbone. I'm talking
fast.
about the backbone. Yes, please.
See, backbone fast is something like if I remove all these things, okay, if I connect a switch over here, I'll explain you clearly. This is my direct link. This port is my blocking port. This is my root bridge. Okay. This is my switch number 3. On this switch number 2, which is having the blocking port, this is my direct link and this is my indirect link. Okay. So on the switch that is having a blocking port, if my direct link goes down, the normal spanning tree will converge the blocking port. This blocking port will come up in 30 seconds. In 30 seconds. Okay. If my indirect link goes down, then the switch 3, if this link goes down, then the switch 3 has to reach the root bridge. So this is the alternate link. It has to go via this port. So in normal spanning tree, what will happen? This blocking port will wait for 20 seconds in blocking state. Then it will move to listening, and then it will move to learning. So total it will take 50 seconds to come up. So to overcome this thing, to overcome this times, to optimize the spanning tree, to converge the spanning tree faster, what we can do? Here for direct link, we can use uplink fast. If we use uplink fast for direct link on this switch 2, what will happen? This time will reduce to 1 second. The direct link will come up. This alternate link will come up in 1 second if my direct link fails. And if I enable backbone fast means this is taking 50 seconds. So this 50 seconds, it will not take 50 seconds. This 20 seconds will be removed. This blocking port will directly move to listening and then learning. So the link will come up in 30 seconds. Okay, previously it was waiting for 20 seconds in the blocking state. Now if I enable backbone fast, it will not wait for 20 seconds in the blocking state. It will directly move to the listening state, learning state, and the link will come up into 30 seconds. Understood? IKIS?
Yes, understood. But do we have to, in the latest Cisco switches, do we have to necessarily?
If it is running RSTP, then there is no need.
Okay.
The latest switches, they are running RSTP only. Okay, so it is something, they are something legacy methods. Okay, they are something legacy methods. Okay, but as a network engineer, you should know that what is uplink fast and what is backbone fast. Understood?
Yes, please. Thank you.
Here we have completed our STP topic. Let us move to the next. Okay, so let us see what is trunk. So we all know what is trunk, correct? What is trunk? Trunk will carry multiple VLAN traffics from a single link. Okay, so what are the common issues that can occur if we want to troubleshoot a trunk? If we have given a command, switch port mode trunk, switch port trunk encapsulation .1q we have enabled, but the link is not forming trunk. Okay, but the link is not forming trunk. So what can be the issues? So these are the common issues to troubleshoot if the link is not forming trunk. So the common issues are either that can be an encapsulation mismatch. We'll see trunking mode mismatch, allowed VLANs mismatch, or native VLAN mismatch. So these are the common issues that can be there. So whenever you are troubleshooting a trunk link, you need to check these all things. Whenever the trunk is not getting formed, you need to check these all common issues, whether there is any of these common issues there in the link. Okay, so mismatch, encapsulation mismatch means one side of the switch is running the Cisco proprietary, or you can say the legacy method ISL, inter switch links, a Cisco proprietary trunking protocol, and the other side of the switch is running IEEE 802.1q. This can be the issue that both the switches are not forming trunk. One of the port is running ISL, another port is running 802.1q. Now, what is the difference between ISL and 802.1q? ISL is Cisco proprietary, it is open standard. It works with Ethernet, token ring, and FDDI. It works only with Ethernet. Now it adds 30 byte of tag. This is the most disadvantage. It only adds 4 byte of tag. Okay, and it will be added to the original frame. Now all VLAN traffic is tagged over here. So this is the basic difference between ISL and IEEE. So first common issue is encapsulation mismatch. Next is trunking mode. Trunking mode means there are different modes like access, trunk, dynamic desirable, and dynamic auto. Okay, access means forces the port to operate in access port. Trunk means forces the port to operate in as trunk port. Dynamic desirable initiate the negotiation of the trunk, means if I am having two switches over here and they are connected with a single link, if I make this port as dynamic desirable and this switch as also dynamic auto, then this switch will negotiate that, okay, I am negotiating you to make this port as trunk port. Okay, so unless this is negotiating, this will not make the port as trunk port. Okay, one is it will request once it will receive a request, then only the dynamic auto will make it as trunk port. So dynamic auto passively waits for the remote switch to initiate the negotiation of the trunk. It will wait for the dynamic desirable. If you have made both of the switches as you can say dynamic auto, then no one will become like, if you make this as dynamic auto and this is also dynamic auto, then both will show their attitude. Both will not start the negotiation. Okay, you can say both will show their attitude that no, I will not start the negotiation. I will not start the negotiation. Okay, so there are some modes that you can keep. So if you keep switch 1 at access and let it be any of the mode in switch 2, they will never form trunk because one of the port is access port. Okay, trunk and dynamic desirable will form trunk. Trunk and dynamic auto will form trunk. Trunk and trunk will form trunk. Dynamic desirable and dynamic desirable will form trunk. Dynamic desirable and dynamic auto will form trunk. Dynamic auto and dynamic auto will never form trunk. So you need to remember these all things also whenever you are forming trunk links. So these are this is also one common issue, trunking mode. Okay. Allowed VLANs. Now we have done some VTP pruning. We have enabled VTP and we are doing some VTP pruning. We are pruning some of the VLANs from a particular switch. Pruning means what?
To restrict unnecessary VLAN on the trunk
Yes,
link to a
perfect.
switch. Yeah.
To restrict the unnecessary VLANs. Just give me a second. Pruning means restrict the unnecessary VLANs, correct? Now, pruning, suppose we have enabled pruning on one of the switch and on the other switch all the VLANs are allowed, then this might be the issue. Okay, default all VLANs are allowed. Pruning means specified VLANs to be allowed or denied. Okay, it can improve your security and performance. So if one of the side of the switch is allowed by all VLANs and another side of the switch is not allowed, is denying some of the VLANs, then that might be the reason for the switch to be denied. Okay, understood? Native VLAN mismatch. Now, native VLAN mismatch, if native VLAN is the VLAN, okay, you can say the default VLAN is native, the default native VLAN is VLAN 1. Okay, by default VLAN 1 is the by default native VLAN. Now, native VLAN is something if we don't make the native VLAN, if we change the native VLAN on one side of the switch and on the other side of the switch, if we don't change the native VLAN, they will not form the trunk. They will not form trunk. Understood? Show ether channel, show interface trunk, show interface, any interface number and switch port. These are the verification commands that you can give. Okay. If you need to see the practical, want to see the practical? So by default, this will be running something enable config T, VLAN 10, VLAN 20, VLAN 30. Okay. Then I can say show VLAN brief. So I'm having some VLANs created over here. 3 VLANs I've created. Over here also I'll create some VLANs. Enable config T, show VLAN, sorry, VLAN 10, 20 and 30. Okay, we can use VTP also over here. Show VLAN brief. Okay, show VLAN brief will give me the VLANs that I've created. Encapsulation mismatch. 3 and 4, so switch 3. So how to form trunk? Interface range I will give fast Ethernet 0/1 to 4. I'll say switch port mode trunk, and I'll say switch port mode trunk. Okay, show interface trunk. So by default it is running 802.1q. Okay, you can see encapsulation type over here 802.1q. Switch 4. Why it is blocking? I've taken new switch only, right? Okay. Interface fast Ethernet 0/1 to 4 range. Switch port mode trunk. Switch port trunk encapsulation. It will not give me switch port mode trunk. Show interface trunk. So here it will not give me the option for this. Let me move to this switch only. Stop selected. Enable config T VLAN 10 20 30 on switch 2 enable VLAN 10 20 30 show VLAN brief. Okay, show VLAN brief. Okay, interface range Ethernet 0/0 to 3. I'll say switch port trunk encapsulation. Here I can select encapsulation, so I'll select .1q on switch 1. Switch port mode trunk. On switch 2, I'll say interface range Ethernet 0/0 to 3. Switch port trunk encapsulation ISL. Switch port mode trunk. Now they will not form trunk. Show interface trunk. They will not form trunk. Why? Because there is an ISL encapsulation over here, and on the switch 1 there is an show interface trunk 802.1q encapsulation. So show interface E0/0 switch port. You can get over here trunk negotiation mode on. Okay, encapsulation .1q over here. Okay. Now they will never form the trunk. They will never form trunk because the encapsulation we have mismatched over there. We have mismatched the encapsulation. Okay, so whenever you want to make trunk, the encapsulation should be either ISL on both the sides, or either you can say switch port, sorry, interface range, switch port, mode, trunk, switch port, trunk, encapsulation, .1q. Now this is running as a trunk port. Okay, understood? Like this you can see for all these mismatch. Okay, trunk mode, or you can say encapsulation mismatch, or trunk mode, or allowed VLANs, pruning, and native VLAN mismatch. You can see these things. So this is the way to troubleshoot our trunk links. Now we have something known as ether channel. What is ether channel?
Are you combining links?
Making a bundle. Why we use ether channel?
More throughput?
To increase the bandwidth. We use ether channel to increase the bandwidth. Correct?
To increase the bandwidth and to make redundancy, right?
Yes. To make redundancy also. Now, what we are having over here, troubleshooting ether channel. What are the issues that can be formed? Now, how the ether channel is formed? So we are having two protocols, PAGP and LACP. Okay, first we'll see how these things are formed, how the ether channels are formed. So if you are using port aggregation, PACP, you can say PAGP, PACP port negotiation. Then if you select on and on, switch 1 is on and switch 2 is on, port channel will be formed, or ether channel will be formed. Switch 1 is on, or either it will be auto or desirable. The ether channel will not be formed. Same as over here, auto and auto will not form, auto and on will not form ether channel. Auto and auto will also not form ether channel. Auto and desirable will form ether channel, because desirable is something it will negotiate. This will negotiate desirable. It will negotiate. Desirable and on will not form desirable, and desirable and desirable and auto can form the ether channel. Okay, in our PAGP. In LACP, we have active and passive, same as auto and desirable. Here, auto means passive and desirable means active. Okay, so on and on will form, on and passive or active will not form. Passive and on will not form, passive and active and on will also not form. Passive and passive will never form, because passive is something it will not negotiate. Active is it will negotiate, like desirable. Okay. LACP. Now load balancing algorithm, how it works, how the load balancing algorithm works. Suppose we are using the destination MAC. Okay, source IP and source. See, these are the load balancing algorithms that we can use. We can select any one of them. So we can select those destination IP, destination MAC, source destination IP, source destination MAC. Okay, so see how it works. So if I select destination MAC, suppose if I'm selecting destination MAC and I'm having 3 servers on the destination MAC. Now, how it will select? Okay, so load balancing, how it will select. So if you want to load balance the traffic, how it will select the things. So suppose these are the MAC addresses of the servers. Okay. So what it will do, it will make the hexadecimal. These are in hexadecimal. So it will convert it into binary. So this is the binary for 1, this is the binary for 5, and this is the binary for what? D. D means what? D means 13. D means 13. So 12 plus 4 is 12. Sorry, 8 plus 4 is 12 and 1 13. Okay, so binary conversion, hexadecimal to binary. So now these are the digits that are given to the links 0 0 0 1 1 0 and 1 1 because we are having 4 links. Okay, 4 link bundle. So these are the binary numbers that are assigned. Now this link will take the last digits, okay, or it will take the last digits over here, and it will see the what are the last two digits of the binary of all the servers. Now here all the servers are having the binary digits. Like if I want to reach server 1 with the MAC address of 1, then from where I can go from 0 1. If I want to reach 5, I can go from 0 1. If I want to reach D, I can go from 0 1, link number 0 1. Here all are having same, but if I would have F over here, suppose F means 15, 15 means 1 1 1 1. F means 1 1 1 1. Now 1 1 is the link. So if I want to reach the server F, the server that is having a MAC address of F, I will use this link. I will use this link. So in this way, the load balancing algorithm is been used. So we can use source destination IP. It will check for particular source, suppose for particular MAC address A, source and destination, and the destination is this. So it will go via as per that source and destination IP, source and destination MAC. So you can select any one of them. Okay. Understood? This is the load balancing algorithm that you can use.
I'm not sure I understand, please. You can. I don't understand the concept well, please.
I cannot hear you.
I don't understand the concept well, yeah.
You didn't understood the concept?
Yes, please.
Okay. So, see, you know hexadecimal to binary conversion?
Yes, we know.
You know?
Yes, I know. I know.
Okay. So, this is the conversion of all the numbers. Now, suppose what I selected that on PC, suppose I am having a PC1 over here and I want to reach any of the server over here on switch B, and I formed the ether channel. Okay, so we are having 4 link bundle, and each link in the bundle is given with a binary digit 0 0 0 1 because we can form 4 combination. Okay, so we have taken 2-bit number over here, 2-bit over here, we can form a 4 in the 4-bit number. Okay, so 4 links in the 4 links. So we can select any of the this load balancing algorithm. So suppose I have selected this one because I am having MAC addresses over here in this example. I selected my PC. If my PC1 is sending any data, or if we want to access any of the server, what it will do, it will use destination MAC for using the link. For using the link, which link it should use? It should see the destination MAC. It should see the destination MAC to reach the switch B. Okay, and see it might be using any one of the link. So how it is selecting any one of the link? It is selecting based on the load balancing algorithm that we select. Okay, so suppose I selected destination MAC. It should see if the destination MAC is having, if the destination MAC is D, then D is having the binary digit as this. So it will consider only the last 2 binary numbers, and the last 2 binary number are 0 1. So 0 1 means this is 0 1. This is given as the 0 1. So any MAC address that is having the last 2 digit as 0 1 will use this link to send the traffic.
Can you also explain about source destination IP? A small example on that.
So destination IP means it will check the specific source. Suppose I am having over here 1.1 and here I am having 1.2. So for 1.1, I will
Is
select.
it the last 2 octet or first 2 octet? 1.1.
Here it will select the IP last two, not the last 2 octet, last 2 digits. What are the last 2 digits? So 1.1 means if I convert the last octet in 1. So if I select 1 means this will be 1. Correct. So last 2 digits are 0, 1. Correct.
Yeah.
1.1 and 1.2 means last 2 digits will be 1, 0. Correct. 1, 0. So it can either use this link or it can either use this link. Both of the link it can use to send the traffic. Understood?
Uh,
Source
Yes.
destination
And
IP.
I have one question.
Yes.
You say that it's looking at the last 2 octets. Is that based on how many ether channels you have? So if I were to do 8, would
If
I
we
be
have
looking at
8,
a?
then it will be it will be having 3 bits. Last 3 bits.
Okay, that's what I was thinking. Thank you.
how
Also,
do we enable ether channel? Is there any command to enable it, or it's
Yes, we are
enabled
having
by
a command.
default on LSCP and PHP?
We are having a
Okay.
command.
And then we also put which algorithm, right, in the command.
Sorry?
And we also define which algorithm in the command, right?
Yeah, we can select the algorithm over here. So I might be having the command over here written. Load balancing algorithm. So you can check the load balancing. Okay, you can check if you are forming a ether channel, how you can check. Show ether channel load balance. Okay, there is no ether channel over here. Default it uses source destination IP. Normally it uses source destination IP by default.
so what happened if you did not define any load balancing?
By default it will
What
use
happened?
source destination IP if you don't define anything. If you want to define, there was a command ether channel. What was the command? Ether channel. The command was interface Ethernet 0/0 ether channel. What was the command? I'm just forgetting the command. I just forgot
Isn't
the
it
command.
under? It's under the channel group, isn't it?
Yeah, it will be under the channel interface. So I have not formed any channel right now. Is it under the channel, Robert?
I thought it was. I can check.
Okay. Let me connect 2 links and form an ether channel. So Robert, how to form an ether channel?
To form an ether channel, you go to the interface and the channel group.
What did you say?
So you channel group and 1, and then you'll say mode, I think. Yeah, mode. And then you'll set it to auto or desirable or
Auto.
however you want to do, depending on PACP and OSCP.
Okay, I have done auto over here. And over here, what I'll do, I'll make it as interface range Ethernet 0/0 to 1 channel group 1 and mode will be, suppose if I select auto, they will not form ether channel.
They should form, right? Auto will form.
Auto will form ether channel.
No, auto won't.
PAGP. Auto is not forming the ether channel. Okay. So interface port channel 1. Why? I don't think so. It is.
I think from here you do port channel load balance or not from global
In the
config.
in over here port channel.
Yeah. Now that you've created one,
Port
you do
channel
load balance.
load balance. See here you can select. Here you can select the things which you want. By default it will select source destination IP. Understood?
One question on it. So destination IP, obviously it's where it's destined to. Source IP, where it's sourced at. When it says source destination IP, can you just kind of explain that? Is it looking at the source IP address and the destination IP address?
See,
Or
source, it will do XOR between source and destination IP address. It does XOR. XOR, you know XOR?
no, I'm sorry.
See, I also somewhat forgot about XOR. XOR is something it will multiply, it will combine both the things, and what is the output? It will check the output. XOR. Okay. So let us check XOR logic. XOR logic for ether channel.
You are also sure about auto will not make a channel.
Yes.
Auto will not establish channel.
Yes.
So it should be active, passive, right? Sorry.
See, active is for
Okay.
LACP.
Okay. Actually, I'm seeing in my notes it's AA. I was expecting auto. It is actually active for other one. LS. Correct.
Yeah. Active can form. Active can form. Passive and passive cannot form. Got it?
Yeah.
What is logic gate? XOR, gate circuit diagram, XOR. I also forgot about this XOR. It is giving me the circuits.
If you just see the formula, XOR formula, it will be clear.
Yeah.
It is and plus.
See
plus
over
and
here.
Multiply.
Here over here. XOR formula is given over here. Ether channel. If suppose I am having something like on one side the IP address is 1.3. Okay. So 1.3 and the other side the IP address is something so it is given a bundle of 4 links of 2 bits. Okay, so if index is equal to 0, link 0 is selected. If index is 1, then 1 is selected. If index is 1, link 1 is selected, so forth. The hashing is formed using XOR operation. Now let us take an example of source and destination IP based traffic. So source IP is 10.0.0.1 and destination IP is 1.3. So the rightmost bits are used for XOR operation. If you have 4 link bundle, 2 bits are required for the last octet, from the last octet, as I told you, 2 bits. So in case 01 from 10.01, because this will be the last 2 if I am forming 1, and 11 will be from this 1 dot this 3 1 dot the 3 will be 1 1 1, and it will form like this. So 01 or XOR 1 1. If we do 01 XOR 1 1, then it will be like this. The output will be 1 0. Okay, which is 2 decimal. Therefore, link 2 is selected for traffic forwarding. Understood? XOR is done something like 0, 1 will be 1 and 1, 1 something like this. I'm not getting the
XOR, in XOR, if both the input are opposite, either 0 or 1, then the output will be 1. And if both the input is same, like 1, 1, then the output is 0.
1, 1 will be 0. So I will get like this, correct?
Yeah.
0, 1
If
will
both
be
the
1
yeah.
and 1, 1 will be both the are same. So if both are 0, then I will get 1.
1. Keep that.
And if both
This is
are,
what I
if
remember.
one is 0,
Maybe.
if one is 0 and one is 1, I will get 0.
No. If both are same, both inputs are same, then you will get 0.
Afa, both inputs are same, then I will get 0. If
Yeah, and
one
if
is,
any of the input are both are different, then you will be 1.
you will get 1. So
This is
if I am
the
having 1, 0,
XOR. Yeah, this is the XOR.
I got it now. That makes sense. Thank you.
if I got 1, 1, then I will get
Then again
0.
0.
If I
Yeah.
got 1, 0, 1, then I will
Then
get
again
1.
1. Yeah. This is the XOR operation.
Okay, thank you very much, Pawan.
This is the
Understood?
old engineering school.
So I'm very weak in mathematics. Okay, I hate maths. Okay, so that is the reason I don't remember the things in maths. Okay, understood, Robert, now how it is selected.
Yes, I got it. Thank you.
Okay. Any questions, anyone else? So this is the load balancing algorithm that is being used. Then comes the issues. So port configuration mismatch, PSGP and LACP mismatch, suboptimal load balancing. So let us see one by one. Port configuration mismatch means first, on the first port you have something speed or duplex mismatch or trunk mode mismatch or native mismatch or allowed VLAN mismatch. So these all are the issues that will make the port to participate, that will stop the port to participate in the port channel, in the ether channel. Okay. So might be there is a speed mismatch or duplex mismatch or trunk mode is not properly done or native VLANs on the both the switches are not properly configured or the allowed VLANs we have done pruning but the pruning is not done properly. So in these all situations we cannot form a ether channel. Then PAGP or LACP mismatch. Okay, like any of the mode and one side or either you can say one side you have configured PAGP and another side you have configured LACP. This will also not form ether channel or both the side you have configured PAGP but you have done some mistake like auto and auto or desirable and on or auto and on or something. You have made some mistakes. Okay. Understood?
Yes.
Suboptimal load
Clear.
balancing. One side you have selected source destination IP and the other side you have selected destination IP or something. Suboptimal load balancing. Both the side it should be same. So these are the things how you can check. Show ether channel summary, show interface trunk and show ether channel load balancing. These are the commands that are there to check the ether channel troubleshooting. If you are troubleshooting ether channel, you can check it in these ways. Understood?
Yes.
Yes.
Okay, so let us stop over here for today.
Only one thing, Qayyum, I just one request you, if you can share, the PDF format of this slides, then it will be good for reference, during the exam time. It is very difficult for me to note it down during the class, and even after the class, it takes 2 hours, for to
See,
move
it
the
is not.
videos.
See, Pawan, the thing is that I am not allowed to share these things. Okay, this is something
Mhm.
Octa Networks PDF presentation. You can see I've made it on Octa Network, so I'm not. You can say authorized to share the things.
Okay.
And also, if possible, you can share with us or inform us what topics we are going to treat tomorrow, so that some of us, if we
We
have
will
time,
see
we can read
the
something small
we will see the
before.
nodes. We will see the different versions of spanning tree, like RSTP, per VLAN spanning tree, then MST, or we will see CST. These all things we will see in the next lecture.
Thank
Okay.
you.
Any other questions?